Good morning all of you. In today's session of class 11 physics, we are going to continue with applications of calculus in physics. Now if you remember in the last session, we had a situation that this was the displacement time graph. S is equal to t square plus t, and this was the corresponding velocity time graph v equal to 2t plus 1. And I had mentioned to you that when the time is 1, when velocity is 3, and when the time is 2, the velocity is 5. Now the area under velocity time graph will give you the displacement in this time interval. Now there is a issue that here the velocity time graph area can be calculated easily because it's a regular area, it's a trapezium. But suppose if it is a very obscure kind of a shape, some random shape, then how do you find the area? So what happened was that Sir Isaac Newton, who is basically the founder of calculus, he suggested one method. He said that suppose this is velocity and this is time. So he suggested one method that you take a thin strip, and when you say thin in physics language, it means that it is infinitely thin, and the thickness is dt, and suppose the height is of course the velocity v. So v into dt will be the area of this strip, and if you add all such infinitely thin strips from t equal to 1 to t equal to 2, then the total area is obtained by one symbol called integral. This elongated s, it looks like just imagine you have a s and you have elongated it. So the symbol for integral looks like an elongated s, and you just put the value of the starting time and the ending time above and below. So the starting time is 1 second, you write it below. The ending time is 2 seconds, you write it above. Now when you are doing this integral, so you know that velocity is 2t plus 1. So instead of v dt, you can just write 2t plus 1 dt, and you have to write 1 and 2 on the top and the bottom. Now the formula, just like we did one formula last day, that is d by dt of t to the power n. Similarly, the first formula of integration is also integral t to the power n. So integral t to the power n, the formula is t to the power n plus 1 divided by n plus 1. This is the formula of integral t to the power n. If there is a constant, then here the constant will just be attached. It won't play any role. It will just be passively multiplied, just like it was in the differentiation, the same way. And if there is any plus sign, it will stay there. So let us see now how we can do this integral. So we will write like this: 2 integral t dt, and limits are 1 to 2. Then integral dt. Now the problem is that in our formula it is written t to the power n. So we would like some form of t to be there. So it is written only 1. So usually we are not very happy if only 1 is there. So I will write t to the power 0. Now integral of t is t square by 2, and the limits are 1 to 2, and t to the power 0 will be t, and integral of that will be 1 to 2, right? So if you now look here that t square by 2, when you put 2, so 2 square by 2 is 2, and if you put 1, 1 square by 2 is half. Similarly, t from 1 to 2, so if you put 2 it will be 2, and if you put 1 it will be 1. So after calculation, it is coming to Okay, this will be actually 2 by 2, right? So actually it is 2 square by 2. So this will be 2 plus 2, that is 4. Okay, so let's just go through this again. According to Sir Isaac Newton, if you have a random shape, of velocity time graph, then how will you calculate the area? So he suggested that you divide the area into infinitely thin rectangles. The thickness of each rectangle is dt and the height is v. So v dt will be the area of one rectangle, and if you put this integral symbol, you will get the areas of all the rectangles. And you have to put the lower and higher value of time, like 1 and 2. So you say like this, integral 1 to 2, 2t plus 1 dt. So that is twice integral t dt plus integral, you can't write 1, so you write t to the power 0 dt. And limits are 1 to 2 and 1 to 2. Now integral t is t square by 2. And here also integral t, you just write t. So twice t square by 2 from 1 to 2 plus twice t from 1 to 2. So this is, if you apply the upper limit, so 2 square by 2, if you apply the lower limit 1 square by 2, and you have to subtract them. Here if you apply the upper limit, it will be 2, if you apply the lower limit, it will be 1, and you have to subtract them. So 2 into 2 square by 2 minus 1 square by 2 plus 2 into 2 minus 1, ultimately 2 plus 2, that is 4. So what was the answer of displacement in the interval 1 second to 2 second? 6 minus 2, that is 4. So the answer is matching, right? On the other hand, if you just want a formula for the displacement, okay, if you just want a formula for the displacement, then what you should do is, when you are doing the integral, you should write lower limit as 0, and upper limit you can just write a variable t, just write t. Like sometimes we are not interested in a specific displacement, like here 4 is the specific displacement between 1 second and 2 seconds, but sometimes we may not want the specific displacement, we just want a general formula for displacement. Then in the integral, instead of writing the time as 1 to 2, you write 0 to any variable time like t, and if you continue all these steps, then you will find that your answer will come exactly the displacement time equation, that is t square plus t. You will get exactly that. So this is the technique of integration, right? Now my homework for all of you, as you know that there is another graph, that is acceleration time graph, and you know that between 1 second and 2 seconds, whatever is the area under the acceleration time graph, you all know extremely well that the area under acceleration time graph gives change in velocity. So between 1 second and 2 seconds, the area under this graph will give you the change in velocity, right? What you have to do, this is your homework, you will have to use this technique which I taught you just now, and you will have to find out what will be the change in velocity between 1 second and 2 seconds using this technique, the technique of integration, right? So that is your homework. Using integration, find the area under acceleration time graph between 1 second and 2 seconds, and therefore find the change in velocity between 1 second and 2 seconds. So this is your homework. So that will be all for this session. I'll end now. Thanks a lot and bye all.